Network slicing is a new IPv6 enhanced technology. What if we combine it with BIERv6? Let's take a closer look by configuring BIERv6 network slicing. Here, let's use MVPNv4 over BIERv6 networking as an example to describe how to configure BIERv6 network slicing. In such networking, multicast streams from the multicast source are sent to multiple multicast receivers over BIERv6 tunnels. If network slices are deployed on the MVPNv4 over BIERv6 network, and a network slice ID is configured for each MVPN instance or multicast stream, the network slice interface associated with each network slice ID is used to forward the multicast streams. In this way, the multicast streams of one MVPN instance can be isolated from those of other MVPN instances. In addition, the multicast streams of a specific SG in one MVPN instance can be isolated from other multicast streams in this MVPN instance. The configuration of MVPNv4 over BIERv6 scenario has been described in other courses, so we will not talk about it in this course. Instead, this course will mainly focus on network slicing-related configurations. In terms of the configuration roadmap, there are 3 steps to deploy network slicing on the basis of MVPNv4 over BIERv6. In terms of service logic, in network slicing scenarios, you can configure a unique slice ID for each SG multicast stream in an MVPN instance. The slice IDs are encapsulated in BIERv6 packets. When forwarding a BIERv6 packet, a device searches its unicast routing table based on the destination address in the BIERv6 packet header to determine the outbound interface, and then searches the network slice interface group corresponding to the outbound interface for the network slice interface with the same slice ID as that in the HBH. First, create network slice instances on all involved devices. In this example, we need to create 3 network slice instances with IDs 10, 20, and 30. Of these network slice instance IDs, 10 is for basic multicast services, 20 is for a specified MVPN instance, and 30 is for a specified SG multicast stream. For each network slice, we can configure a description for easier subsequent maintenance. Next, we need to specify base interfaces and create network slice interfaces. After a base interface is specified for network slicing, traffic diverted to this interface is forwarded through the corresponding network slice interface based on network slicing requirements. Network slice interfaces include Flex-E interfaces and channelized sub-interfaces. In this example, Flex-E interfaces are used as network slice interfaces. Other courses cover details about how to configure a Flex-E interface. Let's look at the detailed configuration procedure. 1. Run the network slice data plane command to specify a slice ID for the base interface. 2. Configure a Flex-E interface. 3. Run the basic slice command to associate the Flex-E interface with the base interface. Note that the slice ID specified in this command must be the slice ID of the base interface. Multiple network slice interfaces associated with the same base interface form a network slice interface group. When forwarding a BIERv6 packet, a device searches the network slice interface group corresponding to the outbound interface for the network slice interface that has the same slice ID as that in the HBH. 4. Specify a unique slice ID for each of the 2 Flex-E interfaces on each device to allocate the Flex-E interfaces to corresponding network slices. The configurations of PE2 and PE3 are similar to the configuration of PE1. On the P, we need to specify the interfaces connected to 3 PEs as base interfaces and create network slice interfaces. BIERv6 network slicing needs to be enabled both to the ingress PE1 and transit node P of the BIERv6 tunnel. Only after the network slicing function is enabled can a device search for the corresponding network slice interface based on the slice ID to forward packets. Otherwise, packets are directly forwarded through the base interface. In this example, 2 slice IDs are specified on PE1, one for the MVPN instance and the other for a specified SG multicast stream in the MVPN instance. This associates the MVPN instance and the multicast stream with their corresponding network slices. When PE1 receives a multicast packet of VPNA, it encapsulates the packet with an HBH that contains a slice ID according to the configuration. If both MVPN instance-based configuration and multicast stream-based configuration are performed, the multicast stream for which a slice ID is specified is forwarded through the network slice interface corresponding to this slice ID. And other multicast streams in the MVPN instance are forwarded through the network slice interface corresponding to the slice ID configured for the MVPN instance. We can run this command to check the result. The command output shows that the network slice ID corresponding to this specified multicast stream in VPNA is 30, and that the network slice ID corresponding to other multicast streams is 20. In other words, packets of this specified multicast stream are forwarded through the network slice interface corresponding to slice 30, and other multicast streams in VPNA are forwarded through the network slice interface corresponding to slice 20. Finally, let's talk about the multicast packet forwarding process in the MVPNv4 over BIERv6 network slicing scenario. 1. The original IPv4 packet is sent to PE1 through the interface bound to VPNA. 2. PE1 selects a tunnel based on the multicast source address and multicast group address of the packet, inserts an outer BIERv6 packet header with a bitstring 0110 into the packet, and sets the source DT4 SID to the outer IPv6 source address. PE1 then queries its BIERv6 and obtains the tunnel outbound interface and the next hop, which is the P. So PE1 sets the destination address of the packet to the end BIER SID of the P. In addition, PE1 parses the slice ID from the packet header, encapsulates the slice ID into the HBH, and forwards the packet through the network slice interface corresponding to slice ID. 3. The P parses the slice ID from the packet header and forwards the packet through the network slice interface corresponding to the slice ID. 4. After receiving the multicast packet, PE2 and PE3 each remove the BIERv6 packet header and HBH and forward the packet out of the MVPNv4 over BIERv6 network. The packet then enters the VPN for forwarding. Compared with packet forwarding in a common BIERv6 network slicing scenario, the packet forwarding in a BIERv6 network slicing scenario involves encapsulation of an additional header, HBH, and based on the slice ID in the HBH, packets enter the corresponding network slice for forwarding. Thank you for watching.